This is R.D. Sharma Solution, Class 12th, Chapter 12, Higher Order Derivatives. We are taking the MCQ or multiple choice questions. Now we have x equals to ft cos t minus f dash t sin t. So we have functions only here, and then y is also given, and we have to find out this. So we have already done part of these questions already in our previous discussions. So let us see how we go about it. So just differentiate it and just put it in the formula being given, dx by dt whole square, dy by dt whole square. So let us start. X is equal to ft cos t minus f dash t and sin t. So dx by dt will be, there are two functions here. In the first term, two functions. Second term also two parts. Means two terms, and in every term we have two functions here. So we'll take this term first, ft. I'm applying the product rules. So cos t will be minus sin t. Then we have cos t, and differentiation of ft will be f dash t. Then we have the second part, or you can say second term, and it has two functions. So it will be under the negative. So f dash t will be like this, sin t will be cos t, then plus sin t will remain like that, and f dash t will become f double dash t. So because the differentiation is f double dash t. Now let us open this. Dx by dt will be, there will be certain cancellation here. Minus ft sin t plus cos t f dash t minus f dash t cos t minus sin t f double dash t. So what is the cancellation here? See, f double dash there is nothing. So we have the cancellation will be done for these two. The middle part. Okay, so what will be the final thing? Minus ft sin t minus f double dash t sin t. Now same way we have to find out the second one, dy by dt. So same thing we have to do, ft cos t minus f double dash t cos t. Now we just have to square them. Dy by dt will be the final one. Okay, I am not doing it. I just told you that dy by dt will be done in the same terms, and there will be a cancellation, and final things will be here, and we have to just square it. And since we have a negative for the first term dx by dt, we have just taken the negative out and squared it, so it will be plus only. So we just have to add them, ft f double dash t with sin t, and here also in the second term dy by dt we have cos t terms. So when you square this, sin square will come. So I'm just taking sin square t outside, and the first term I'm taking f dash t, this I'm not doing anything, I'm just squaring it. It is not whole square. So ft plus f double dash t, just make it as square. I'm just taking sin square out because we know sin t is in both the terms. In the second one we have cos square t I'm taking outside. So we have ft plus f double dash t. So these are the two things which are common here. So we can take this common outside, ft plus f double dash t. When you take this out, what will be inside? Sin square t plus cos square t inside. And you know that sin square t plus cos square t is 1. Means sin square theta plus cos square theta is 1. So ft plus f double dash t whole square will come. This is your option. Option C is the correct answer. Now here you have to see, because there are certain things which will be in between, and that will be used in the later part. Alright. So there are certain steps which will be used for the later steps. So we have y raised 1 by n plus y raised minus 1 by n negative 1 by n. This is equal to 2x. Now we have to differentiate this. Please remember, x to the power n differentiation is n x to the power n minus 1. So 1 by n, y to the power 1 by n minus 1. Then you have this negative 1 by n comes in front, y to the power minus 1 by n minus 1, these two. Differentiation of 2x will be 2. So what are we going to get here? Can we make it simpler? Because we have to keep an eye on what is being expected also. X square minus 1 into y2 plus x y1, this is being asked. So this, we have just done one part, because once you differentiate y to the power 1 by n, it will be 1 by n, y to the power 1 by n minus 1. But what about y? There will be dy by dx also in both the terms. So I have to introduce or include y1 also. So this y1, so we'll take y1 outside. y1 is simply the differentiation. 1 by n also we can take out. y1 in the numerator and in the denominator. So y1 by n it is. Now y to the power 1 by n minus 1. And since y to the power 1 by n minus 1 can be written as y to the power 1 by n into y to the power minus 1. Here also y to the power minus 1 by n here, and y to the power minus 1. So we can see that y raised minus 1 is nothing but 1 by y. So that can be taken in the denominator. You just assume that y raised minus 1 is 1 by y. Y can be taken outside. So what we took outside y1 divided by ny, and there are two terms which are inside, y raised 1 by n minus y raised minus 1 by n. So this will remain inside, and other terms can be whatever is in the denominator you can take to the numerator of the other side. So n into y I am taking on the right hand side, it is 2ny. So this we are going to reuse. I mean we are going to replace somewhere. So what we have got up till now is y raised 1 by n minus y raised minus 1 by n into y1 is equal to 2ny. Alright, now let us differentiate this, because there is y2 in the question, so we have to differentiate it again. So I am applying the product rule. The first one is like that, then y1 will become y2. Now y1 will remain like that, and y raised 1 by n minus y raised minus 1 by n we have already differentiated with a positive sign. Same thing will be happening here with a negative sign in between. But when we differentiate this, we know that the second part of y raised minus 1 by 1 there will be plus in between, because negative will come, because minus 1 by 1 will come in front. And this is going to be 2n, and differentiate, because 2n is constant, only differentiation of y will be done, that is y1. So this n is in the denominator. Why don't we multiply everything with n? Because we want to just eliminate this n in the denominator. Alright, and y raised 1 by n minus 1 or y raised minus 1 by n minus 1, in the previous step, just few seconds back, I told you y raised minus 1 can be written as 1 by y. So we have n from the denominator, y again from the denominator, that is y raised minus 1. So we have this ny in the denominator. So what do we get? I am multiplying now. Okay, multiplying everything with ny. So the first term will be multiplied by ny, so it will be ny y2 whatever is inside. Then we have y1 square, because ny is already being multiplied. On the right hand side we have 2n y1, and ny is to be multiplied. 2n y1 is there. We have to multiply it by y, so it will be 2n square y by 1. Now what do we see here? As I told, we are going to use it. So why don't we divide everything with y1? We are dividing everything with y1. This is not y, this is y1. This gets cancelled. Here 2ny is there. So in order to bring this, if I bring this y1 in this particular step, 2ny by y1, and we already have ny by y1. So in place of ny by y1, I can write or replace it by y raised 1 by n minus y raised minus 1 by n divided by 2. This is already there. Y 1 by n minus y raised minus 1 by n. So we have replaced this y raised 1 by n minus y raised minus 1 by n into y1 equals 2ny in this step. Rest thing remains like that. y1 was there, this term with plus sign, and on the right hand side already y1 is eliminated now. So these are two things similar, so we can just square it. Y raised 1 by n minus y raised 1 by 1 whole square. This is y2 by 2. Now see, we have a minus b whole square can be written as a plus b whole square minus 4. A minus b whole square will be equal to a plus b whole square minus 4. This y raised 1 by n minus y raised 1 by minus 1 by n square is nothing but y raised 1 by n plus y raised minus 1 by 1 minus 4. So I am replacing this term with the formula which I just gave you with this thing. Okay, alright. So let us see this. A plus b whole square, that is the y raised 1 by n plus y raised minus 1 by 1 is already with us. It is 2x, and 2x whole square is going to be 4x square. So this whole, by the formula I just introduced, this can be written as 2x square, that is 4x square. So this is 4x square minus 1, which I got just now, and then we have other things remaining. I'm just writing like that. Okay, all other things are there. So just this 2 can be replaced. We already have x square minus 1 now with a y2. So just divide everything by 2. I'm cancelling 2. X square minus 1 into y2 is there. We have x y1, and on the right hand side we have x square y. Oh, n square y, sorry. So on the right hand side we have n square y. This is the answer. Okay, I hope you got the idea. This is the step which is the trick. A minus b whole square is a plus b whole square minus 4. Now we have d by dx of this term. This is a series multiplied by e to the power x is equal to x raised n e to the power x. Now we have to tell the value of AR. AR is what? A1, then we have A2, A3. So what will be AR? If we are able to find out A1, A2 and A3, then we can form a pattern or a series. So the d by dx is of two terms. First is the series, and second is e raised x. I am writing one as p, writing other thing as q. So p multiplied by q. So we have to follow the product rule. So e to the power x differentiation. Let us take this e to the power x, and the inside content will be see. First I am differentiating e to the power x. So the p term which I designated will come as it is like that. So I am writing the series as it is. Only differentiated e to the power x, which eventually comes to e to the power x only. Then we have plus. Now e to the power x will remain like that, and now I am differentiating the p term. which is nx to the power n minus 1. X to the power n differentiation is like this, minus a1, differentiation of x to the power minus n minus 1 is n minus 1, x to the power n minus 1 minus 1, that is n minus 2. Then we have plus. I'm not writing whole of the term because you will be able to know that there is a pattern which is being followed, right? So I hope you will be able to differentiate all of this. So you need to know the binomial theorem and binomial stuff, because this is what is being applied here. So I'm taking this e to the power x common from both the terms. So inside it will be x to the power n. Now I'm taking x to the power n minus 1 common. So what is being inside? N minus a1. Then we have x to the power n minus 2. And what do we have inside? a2 minus a1 into n minus 1. So I'm just taking e to the power x outside, other things with the term similar, that is the power of x, wherever it is similar, I am combining those terms. That is the only thing which I am doing right now. So we have x raised n, x raised n minus 1, then x raised n minus 2. So there will be multiple terms here, and you will know what will be the final term. Now this is equal to x to the power n e to the power x. Alright, now just equate this. So x to the power n e to the power x is already there. So all the other terms are going to be 0. That is x to the power n minus 1, there is no coefficient here. X to the power n minus 2, no coefficient here. So n minus a1 is equal to 0. Similarly here a2 minus a1 into n minus 1 is equal to 0. So the first term gives a1 equal to n. The second term just replace a1 by n. So you'll get a2 as a1 into n minus 1. So a1 is this, a2 is this. When you do the a3 term, it will be n minus 1, n minus 2. I'm not doing it in the short form because you know already, if you are aware of the binomial, then this is quite simple for you. Then we have an will be n minus 1, n minus r minus 1. That will be the final term or rth term. So this n minus 1, n minus 2, it goes up to n minus r minus 1, and this is going to be equal to ar. So the ar term or the rth term between 0 and n, if r is belonging, then ar is going to be n minus 1, n minus 2, and this goes up to n minus r minus 1, and this is nothing but factorial n by factorial n minus r. Alright, so this is the C option is the correct option. Next is y is equal to x to the power n minus 1 log x, then x square into y2 plus 3 minus 2n into x y1 is equal to. So those who have already done a lot of questions and they are comfortable, they can go ahead with the reference I have provided. Those who want to follow, let us solve it. Y is equal to x raised n minus 1 log x. So y1, the first term is x raised n minus 1, the second term is log x. So let it be p into q form. We are going to apply the product rule. So log x is 1 by x plus log x will remain like that. X raised n minus 1 differentiation is n minus 1 into x to the power n minus 2. So I'm taking x in the denominator now. So here it will be x to the power n minus 1 plus log x n minus 1 x to the power n minus 1. So there will be x. So x n minus 2 into x to the power 1. This is y1. We wanted x y1. So let us multiply both sides by x. So you'll get x y1. One term we have got. So this is going to be equal to x. See, x raised to the power n minus 1 into log x is already y. So we can replace it here. This x raised to the power minus 1 and log x can be replaced by y. Alright. So this is going to be x to the power n minus 1 plus n minus 1 into this whole I am replacing it by y. Okay. So we have x, y1 will be y2 plus y1, differentiation of x will be 1. So n minus 1, x to the power n minus 1 will be n minus 1, x to the power n minus 2. Then constant is n minus 1. Differentiation is y, differentiation of y is y1. Okay. So this is xy2 and we need this 3 minus 2n terms. So how are we going to get this? Let us see. N minus 1 into x to the power n minus 2. So x to the power n minus 2 can be written as x to the power n minus 1 into x to the power minus 1. When you add this, it's going to be n minus 2 in the power. So I'm writing this x to the power n minus 2 as x to the power n minus 1 divided by x. I hope you got the idea. Now you see that we need x square y2. We need all the term which is on the right. So x square y2. I'm multiplying everything with x now. X square y2 plus x y1 is equal to x to the power n minus 1, and this x will go, this is n minus 1 into plus n minus 1 into y1 into x, because we have multiplied it by x. So this we got this x raised n minus 1, n minus 1 into y1 dot x. So x raised n minus 1. So we have to write certain thing which we have already done. We have to replace it because there is no x raised n minus 1 in the final answer. or x raised n minus 1 will take it from here, this particular step. So x raised n minus 1 can be, because n minus 1 into y can be taken on one side, so x raised n minus 1 can be written as xy1 minus n minus 1 into y. So x square y2 plus xy1 will be equal to xy1 minus n minus 1 into y. N minus 1 is already there, and then we have x into y1 into n minus 1. I hope you have a better understanding now. So x square y2 plus xy1 is equal to xy1 into n minus 1 minus n minus 1 whole square into y x y1 into n minus 1. Now they are similar terms, so you can just add them up. It will be twice of x y1 into n minus 1. Now take this on the left hand side, x square y2 plus x y1 minus 2x into n minus 1 into y1. This is going to be equal to negative n minus 1 whole square into y. What do we want? X square y2 plus 3 in minus 2n into xy1. So 3 minus 2n, how are we going to get? Okay, this is the basic thing. Now this is xy1, this is xy1, they both have xy1 term, they both have xy1. So xy1 minus 2xy1 n minus 1 xy1, you can just take common, it will be 1 minus n 2 twice of n minus 1, and this is going to be xy1 1 minus 2n minus plus 2. So this is 3 minus 2n, and that is what we wanted. 3 minus 2n, 2n has come. X square y2 plus 3 minus 2n into xy1 is equal to negative n minus 1 whole square into y. This is your final option. Xy minus log y is equal to 1 satisfies equation. This you have to find out the value of lambda, because on the left what is being sought is a lambda, which is a constant, and lambda has to be computed. So what do we have? Xy minus log y is equal to 1. So we have xy minus log y. So we have y1 also and we have y2 also. So simply we have to differentiate it twice, y1 and y2. So x, first term, x, y1, then we have y. Differentiation of x will be 1 only. Log y is 1 by y, and differentiation of y will be dy by dx. You can write it as y1, and this is going to be 0. Now multiply everything with y. So x y1 into y plus y square minus y1 is equal to 0. So we have to differentiate it again, because we need lambda. There will be certain term with y1 that is going to come for sure. So since we have y2 also, we have to differentiate it now again. And since we have two terms here, x y1 into y, three terms actually. So we have to differentiate with respect to or following the product rule, taking two at a time. Means one differentiation, two will not be touched. So I am doing the second and third term first. Y square is 2y, then differentiation of y is y1. y1 differentiation is y2. Now doing x y1 y. Now x y1 will remain there, whereas differentiation of y will be y1. Now let us take y1 and y untouched, and differentiation of x will be 1. Now let us take x y here, and differentiation of y1 will be going to be y2, and this is going to be equal to 0. Now take those terms which are similar, we can add them. So we have 2y y1 and we have y y1 also. This y1 will be y1 square. This is x y y2. So we have x y1 square plus y y2 minus y2, and 2y y1 and y y1 will become 3y y1 is equal to 0. Now just equate this with the equation being provided to us. When you equate this, lambda is going to be 3. So what is the value of lambda? It's 3. Y square is ax square plus bx plus c. Then we have to find out y cube d2y by dx 3. Whether it is a constant, well, let me tell you in advance, it is a constant, how it is going to come. So y square is equal to ax square plus bx plus c. Now this y square term we are going to replace. We'll just find a better place to replace it. Let us differentiate it. It is 2y dy by dx is equal to y square differentiation is 2y dy by dx. On the right we have ax square, so it will be 2ax, bx will be b, and c will be 0. One more differentiation, 2 will be outside, so y d2y by dx2 plus then 2 dy by dx. Differentiation of dy by dx will again be dy by dx, so it will be dy by dx whole square, and this is going to be equal to b will be 0, 2ax will be 2a only. So what is 2 doing here? Let us eliminate all of it by dividing it by 2. So we have y d2y by dx2 plus dy by dx whole square equals a. Now we are still not done, because we need d2y by dx2 with y cube. So dy by dx we have already done, and dy by dx whole square we want. So this can be replaced. Dy by dx was what? In the second step. Dy by dx can be written as 2ax by b by 2y. So I am replacing now dy by dx as 2ax plus b by 2y, or 2 gets cancelled, sorry. So we have y d2y by dx2 plus just square it, 2ax plus b by 2y whole square. This is going to be 4y square, and right hand side is going to be, I'm just replacing, not differentiating. So let us multiply everything with 4y square. So y into 4y square is 4y cube dy by dx2 plus 2ax plus b whole square. This will be eliminated. On the right we are going to get 4y square we have multiplied, and a is already there. So 4ay square. So 4y cube. So we need this 4 to be eliminated somewhere. So let us see what are we going to get. Let us bring this on the right hand side. 2ax plus b square on the right hand side. So 4ay square. Oh, here y square can be replaced. As I told you, y square will be replaced somewhere. Y square can be replaced as ax square plus bx plus c here. So you get 4y cube d2y by dx2 is equal to 4ay square. In place of y square, I'm replacing it by ax square plus bx plus c. On the right, it is 2ax plus b whole square subtracted. Now, this is divided by 4. So when you resolve this, 2ax plus b whole square is 4a square x square plus b square plus 4axb. I'm not writing it. I'm just telling you that there will be an opening and there will be a cancellation. 4a square x square will be cancelled and 4abx will be cancelled. Only 4ac minus b square by 4 will remain. I'll just show it to you here. When you open this, a plus b whole square, when you multiply this, what terms will be get cancelled? 4ac and b square will remain. 4a square x square will get cancelled. 4axb gets cancelled. So on the right you will have 4ac minus b square by 4. This is all constant. There is no x and y. So this is a constant term. What is the option we got? The first option is a constant, and that is going to be your answer. Okay, this is all about this exercise. Thank you so much and take care of yourself.